So to make sure that you will be understanding this concept on the Z table, you need to make sure that you are remembering our work or our lesson on normal curve. So recap of what we did 2 weeks ago, because last week we did standard deviation. In a normal distribution, with 66 as the mean and 2.5 as our standard deviation. So this is our mean and this is our standard deviation. This is basically a code or a symbol that we use in statistics, which is a normally. Okay. And we've learned that using the standard deviation, we'll be able to separate what are the 3 percentages in our normal distribution. We call it the empirical rule. The 1 standard deviation away from the mean, the 2 standard deviation away from the mean, and the 3 standard deviation away from the mean. Thank you, Mary, for giving us the notes. 68%, 95%, 99.7% rule. All right, so this is the empirical rule. Now, what is the importance of the empirical rule? We know that if we have an empirical rule, we can divide this 3 partition . So this is our 3 standard deviation away from the mean. So we know that this is 68%. We know that this is 95%. And we know that this is the 99.7% or 99.7% away from the mean. So we have 1, 2, 3 standard deviation. Using this, we know that we can find the percentages of individuals for this normal distribution. For example, the question is, okay, can you please give me the value of the percentage of students whose height is below 66 inches? James says 50%. And that is correct, because 66 is the middle. And we know that this is 50% and this is 50%. Lower 50, upper 50. Then what if I want to know, how are you going to compute for that? Height is below 61 inches. So if it's below 61 inches, that means this is 61. Is it 2.1%? So you are adding the area here and the area right here. So it should be 2.5%. So for those of you who are not understand the 2.5%, remember in the modified version, we have 0.15% and 2.35%. Those are the 2 area under the curve that you're going to add. So the reason why it's 2.5 is because this area is 0.15% and this area is 2.35%, and you add them up and it's equal to 2.5%. So that's basically how we got 2.5. Can you please give me the height of student whose height is above 68.5 inches? Yes. So make sure to include the 0.15% because that's basically this. So 68.5 is this area under the curve, and it's covering all of these area. So you need to add this, you need to add this, and you need to add this. And in our notes, this area right here is 13.5%. This area right here is 2.35%. And this tiny area right here is 0.15%. So a total of 16%. So in statistics, although we are approximating or estimating, there is a science or there's a mathematical procedure on why we're getting all of these answers. So make sure that you're not leaving out all those values that you need for your calculation. Our lesson is obviously not going to be this. Our lesson is a new lesson. What if, I'm going to show this. What if the question is, percent of students whose height is below 65 inches. I think I know why you say why you said it's 49%. It's because it's not 66, and we know that 66% and below is 50%, and 65 is approximately somewhere here. So you assume that it's 49%. The logic is there, but that's not the actual value. Anna says 65 is between 63.5 and 66. 63.5 and 66, and that is correct. And it's not shown or identified on the chart. There's no values in our chart that has 65 inches in it. So we need additional help. Using the empirical rule, we're not going to be able to answer this. That's why in some mathematical calculations, we have certain limitations. For example, if I ask you to give me the value of square root of 9, can you tell me what the square root of 9 is? Everyone says 3. How about square root of 100? What is the square root of 100? Anna says 10. Maureen says 10. It's 10. Square root of 100 is 10. What is the square root of 1? Square root of 1. Carolyn says 1, Yesenia 1, and you are correct. Now, what if I ask you, what is the square root of 13 without using a calculator, okay? Don't use the calculator. What is the square root of 13? Can you tell me? And that is why in some mathematical problems, sometimes we need extra help. And that's basically the concept of the z-table, because sometimes we can use the empirical rule, but only for certain numbers. Just like the square root of a number, we can find the square root of a number if it's a perfect square. But if it's not a perfect square, we're going to be using the calculator, right? But for today, we're not going to be using the calculator. We're going to be using this instead when we are presented with questions similar to this one. But the first thing that we need to do is to do a little bit of math. So this is a two-step process. We need to do a little bit of math, and that math involves a formula. That is the z-score formula, which is given by x minus mu all over sigma. So this is the formula that we're going to be using so we can find the answer that we're looking for number 6. So that is our goal. Our goal is to be able to answer problem number 6. And to be able to do that, we need to perform the first step, finding the z-score. And the z-score is the formula x minus mu all over sigma. And what does that mean? X minus mean all over standard deviation. That's basically what it means. Now, do we know the mean of our distribution and the standard deviation? Of course, it's given. And the mean and the standard deviation is this: 66 and 2.5. So what we're going to do is we're going to apply the formula. So we will have x is, that is our x, 65. Negative 0.4. That is the value, negative 0.4 or negative 0.4. I just want to add 0 because that is the standard form when you are writing out your decimal value. So negative 0.4. Now, what does negative 0.4 mean? We're going to be using our z-table so that it will make sense. But before that, let's make it a little bit more visual. And how we're going to make it more visual? I'm going to draw around here. 65 inches is probably somewhere there. This is our 65 inches. And we're looking for the percentage below 65 inches. So that means this area under the curve. Now, without any calculation, what we know is that this area could be 49%, 45%, 30%. It should be below 50%, right? It should be below 50%. So that's all we know. It's below 50% or below the average. So a person whose height is 65 inches is below the average, but what is the percentage? For those of you who are using the book, you're seeing this now. Are you seeing this? Yes, 0.4, negative 0.4 is this. Can you see this? 34.6. So that is the percentage of students whose height is below 56 inches. Below 65 inches, just like what we are telling. So this area right here, according to our statistical table, is 34.46. And that is the height of the students who is above 30 or below 65 inches. And why do you have this weird value in your area under the curve? Because now we're using a different method, because the empirical rule is limited to only certain values, probably 6 values if we are going to use the empirical rule. But if we're going to be using our table of values, we can have multiple values. So now, how are we going to visualize this? This is important. You need to visualize this. And to visualize 68 inches, just draw a bell-shaped curve and draw a line in the middle, because the middle is the mean, and it is 66, right? 68 inches is what we're looking for, right? What is 68 inches? Is it below the mean or above the mean? 68 inches is below the mean?
Oh, no, it's not. It's above.
Above the mean. But we're looking for the percent of students whose height is below 68 inches, right? The more visual your solution is, the easier it is to compute for your mathematical answer. Now, what we know without using the table is our area under the curve is above 50%. We don't know how above 50% it is. It could be 75%, it could be 80%, but it can never be 30%, right? So that's all we know. But we need to estimate this, and the z-score formula is x minus mean all over standard deviation. All right, can you give me the z-score? Let's add a
0.8.
0.8.
All right.
0.8.
Yeah, I got 78.81.
So this whole thing is 78.81%. Okay. So are you understanding now the logic behind the z-table? What if the question is number 3? Can you give me a mathematical explanation as to how you are going to give me the value of question number 3, knowing that the height of students is below 68 inches is 78.81, what would be above?
Subtract from 100.
Subtract from 100? Who said that? James, is that you?
Yeah.
James says subtract from 100. Can you please tell me why you say it's subtracting from 100?
It's only 100%, and then subtract 78.81. That gives you the rest of the percentage.
Thank you, James, for enlightening us about the rationale behind the 100%. Now, this is important. Are you paying attention? You always have to subtract your answer from the table with 100%. The question is below. Whatever you're seeing in the table, that is your answer. But if the question is above, your answer should be subtracted from 100. Question number 1. Step 1, find the z-score, because you're not going to be able to use your table of values without the z-score. After you found your z-score, use the table so you can find the answer. The first question is below 70 inches and above 70 or 67 inches. To give you a visual so that it will be a little bit easier for you, I'm going to help you out. Use the formula, of course. Step 1. Use the formula. Z-score is 1.6. Now, this is important. It says below. So it's below 1.6. That means whatever the value in your table, that is your area under the curve. And looking at the table, 1.6 positive. 1.6 positive. This, are you seeing it? 94.52 right here. 94.5%. All right, which makes sense. It's about 50%, and this is 94%. Now the next one, z-score. So the z-score of 0.4, z-score of 0.4 is going to give me, you see 65.54?
Yes.
Yeah.
Yes.
Yeah.
Yes.
65.54, which is above 50%, right?
Yep.
Tell me yes.
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 Now look at your diagram. Do you think this is more than? Do you think this is 65.54%?
No.
Obviously not, because this is your 50% and it's way below that. That's why we're subtracting from 100. Yes, 34.46. You're correct. Are you understanding it now? Okay. 1, 2, 3, 4. Because when I started working on problems like this, it helped me whenever I illustrate the normal curve. Anna got it all. Ike got it all. James got it all. What if the question is this? Now, it's not above, it's not below, it's in between. So this is the last skill that you need to learn today. After this, we're done. We know 66 is in the middle. We're looking for in between.
Do you
60.
mean percent?
Yes, we're looking for the percent of students whose height is in between 60 inches and 66.5 inches, which is about 5 foot tall and 5 foot 5.5 inches tall. Already calculated for 60 and 66.5. We already know it's z-score, right? The z-score is right here. Negative 2.4 and 0.2. All you need to do is to subtract it. You are going to subtract the area in between them to find the area between 60 and 66.5. So what we're going to do is 60 is 0.82. 57.93 minus 0.82 is equal to, use your calculator. And that is the answer. This much right here is 57.11%. Okay, now it's safe to say that every time we're doing in between, you're doing two z-scores and you're going to get the value in between them. Understood? Recap. Below, whatever is in the table, that is your answer. Above, look for the answer and then subtract it from 100. In between, you're going to find the area of the first, area of the second, and subtract it. 66 is always the center because that's my mean. That is the percentage that we are looking for. But the question is, what is that? So we're going to use the z-score so we can use our table of values from the book. $67.3. So the percent of students whose height is in between 64 and 69 inches, 67.3. Congratulations. And I'm happy that all of you here, my regular folks, are continuously coming into my classroom. I know I've been repeating this over and over and over again. This is not an easy math class. We know that. I know that it's hard for me to teach like this. However, you guys tried. It was frustrating at first, but you persevered, and I admire you for not losing your patience and not giving up. Some of your classmates has given up on the first day, and you need to commend yourself for being responsible and taking the responsibility of finishing your course right there on your hand, being self-motivated, being self-disciplined, being self-productive. It's all on you. All right. Bye-bye. I'll see you all next meeting.